I told you a picture is very helpful because you have to kind of know which one is on top. I think I may actually do these a little bit out of order. I'm going to come back to this one. It's a little bit ugly. And you'll know if you set it up wrong because you'll get a negative area at the end. And we know area would be positive. So that's what this is telling us. If by chance you set it up wrong and you get the negative at the end, it's equivalent to just doing the absolute value. So you could just say, okay, I got -5. I know that's wrong, so my correct answer is the absolute value is -5, which is 5. You don't have to rework the whole problem. So if that happens, all you have to do is your absolute value at the very end. So let's try, let's go to this one. I want the area bounded by the curves. Y equals sine of x, y equals cosine of x equals 0, and x equals pi over 2. So I'm starting at 0, ending at pi over 2. Sine of 0 is 0. What's the sine of pi over 2, or 90 degrees? And remember our sine, it's a curve, right? So we could certainly pick more points, or we could just say we know this is curves. So that's my sine of x. Cosine of x. What is the cosine of 0? What's the cosine of 90? 0. And we know that is also. All right, so they meet. Do you remember, when is sine equal to cosine? Think about our hand trick. When are sine and cosine the same? 45 degrees, which is pi over 4. So this middle point, they're equal. Now, if I just integrate from 0 to pi over 2, I'm going to get 0. Because I would have to set up one on top and one on the bottom, right? And since it flips halfway in between, I wouldn't get the correct answer at the end. So I'm going to have to break this up. Just like when we did our absolute values. We have to go from 0 to pi over 4, and then from pi over 4 to pi over 2. From 0 to pi over 4, which one is on top? So I would do top minus bottom, cosine minus sine. From pi over 4 to pi over 2, which one is on top? Sine, so it would flip. Sine minus cosine. So now we integrate. What is the antiderivative of cosine is sine minus, what's the antiderivative of sine? So that would make a plus. So sine x plus cosine x. Okay, over here the antiderivative of sine is 0 cosine x minus the antiderivative of cosine sine. So then if we evaluate sine of pi over 4 is radical 2 over 2, cosine of pi over 4 radical 2 over 2, minus sine of 0 is 0, cosine of 0 is 1. negative cosine of pi over 2 is 0 minus the sine of pi over 2 is 0. And here, yep, negative radical 2 over 2 minus radical 2 over 2. Oh, hold on. What? I made a mistake, don't I? This should be a 1. Sine of pi over 2 is 1. Okay, so radical 2 over 2 plus radical 2 over 2 would just be radical 2 minus 1. And then I have negative 1 plus radical 2. Is that okay? Let's look at this one. It is similar to example 3. So yesterday I told you you could do, or I guess problem 3 on your homework. I told you you could do 1, 2, and 4. Number 3 was a little bit different. It says find the areas enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 6. How is this different than my other problems? The y squared. Usually it's y equals something, right? I could solve for y, but I'm going to have plus and minus, a square root, and it's going to be ugly. And I don't really want to try to integrate a plus and minus, a square root. So what I would suggest on this one is that we work in terms of y. So that means this one, if you solve for x is equal to y plus 1. Over here, subtract your 6 and divide by 2, so 1/2 y squared minus 3 is equal to x. So we're actually going to keep the y in these problems. And that's nicer because now I don't have radicals. Okay. I do still need to know where these things meet because I want the area enclosed by them. I want to figure out where they meet. And if I take everything, I don't really want a fraction, I'm going to multiply by 2. Multiply negative 8 and add to negative 2 would be negative 4 and positive 2. So if I'm graphing these, y equals x minus 1, that's fine, that's a line. Y-intercept is negative 1, slope is 1. Your parabola may not be as easy for you to think about graphing, but we certainly could. We know if y is 4, 4 squared is 16, times a half is 8, minus 3 is 5, so x would be 5. So 5, 4. That's the point on my parabola. I'm just estimating. I'm not making a real accurate graph here. If my y is negative 2 squared is 4, times a half is 2, minus 3 is negative 1, so the x would be negative 1. You could put in more if you needed to. You could put in like when y is 0. Then you get negative 3. So that's even further down here. So we should kind of be able to see, okay, from my really rough sketch, it's going to look something like this. Okay, the y squared just makes a parabola on its side. Obviously, my graph was a very rough sketch. You can make it more accurate. You can make a t-chart if you need to write out those points. X squared is a parabola, y squared just flips the parabola on its side. So now when we integrate, if I'm doing it in terms of y, everything has to be a y. So when I set this up, I need my y values. So my lowest y was -2, my highest y is 4. That means this will be a dy at the end. That means everything in here has to be with a variable y. Now when we're doing it in terms of x, we do top minus bottom. Here think of it as right minus left. So the rightmost one is my line, which is y plus 1. On the left, I have my parabola. So 1 half y squared minus 2. Have I lost anybody? And you're welcome to clean up if you want. So it'll be 1 half y squared plus y plus 4. So if I add 1 to my power, that's y cubed, so I need a 1/3 in front, times my -1/2 is -1/6. Antiderivative of y would be 1 half y squared. Antiderivative of 4 would be a 4y. Okay, 18. So if you're doing it in terms of x, your limits have to be x values. You have to do top minus the bottom, everything in terms of x. If you're doing it in y's, your limits have to be your y values, and you do the right curve minus the left curve. And you'll know if you did it wrong, how? You'll get a negative. And so then at the end, if I got -18, all I have to say is, oops, should be the absolute value of this. My answer is actually 18. Is that one okay? Let's go to, I did this one yesterday. Let's go to this one. So I want the area of the region bounded by the line y equals 1 half x, and the parabola y squared equals 8 minus x. Do you think you want to do this in terms of x or y? Y. I know that because I don't really want to solve for y and have a plus and minus the square root. So it's easier to solve for x. So if y is equal to 1 half x, that means x would be 2y. Okay, over here, I can subtract my 8, divide by -1, so we get 8 minus y squared. We have to know where these things meet. So we'll know 1 is 2y, 8 minus y squared. So if we factor, that's y plus 4 minus 2. If we set those equal to 0, we get -4 and +2. Okay. So in my integral right now, what that tells me is I'm going to go from -4 to 2. said everything's going to be in terms of y. We need to know how to set it up, so picture, very helpful for that. It doesn't have to be real precise. 1/2 x, that's a line, slope of half, so f1/2. Okay, if you're trying to graph this, you're welcome to just use these points. You put in as many as you need. So you don't have to write down a t-chart, but I feel like maybe it might help me explain where my things are coming from. If my y is 0, then my x is 8. That's all the way over here somewhere. If I put in a 2 for my y, 8 minus 2 squared is 8 minus 4, so my x is 4. 4, 2. If I put in a -2 for my y, -2 squared is 4, 8 minus 4 is 4. And that's really enough for me to kind of see this is a parabola going that way. So I'm finding this area in between. So when I set it up, which one goes first? You do right minus left. Think big minus small. So the bigger x first. So that's my parabola is the curve on the right. So that would be my 8 minus y squared. Minus my left is that line, so 2y. But again, if you mess that part up, you just have to fix it at the end. Do the absolute value of your answer. Okay. So the antiderivative of 8 would be 8y minus the antiderivative of y squared, 1/3 y cubed, minus the antiderivative of 2y would be y squared. Oops. So I'm in a row, I just did. Then I do it 16 times 4/3 times 4, then -4.
Should y squared have been cubed on the 1/3?
Oh, thank you. That's going to change things, won't it? We don't know, we're getting 8/3. And -4 cubed is -64. So thank you. So get 30. All right. Is that okay? I think I am not going to do this one because the intersection is, you have to use the graphing calculator to find it, and since graphing calculators aren't allowed, I should have taken that problem out and replaced it with a different one. So, do you want to do this one today or tomorrow? Want to go ahead and do it, and we'll be done? Okay. It's the same idea, just not as pretty as some of our others. Find the area of the region bounded on the left by x equals 0 and between these two curves. Okay, so I know I'm starting when x is 0. We need to find out where these curves meet to figure out where we're going to end. These are already y equals, so we can work in terms of x. So cross multiply. I'm going to set it equal to 0. There are different options for solving at this point. We could square both sides and that would work. Here, if I bring that over, then I can factor out an x. So then I just have to set both parts to 0. So x equals 0, we already had that as our starting point. Square root of x squared plus 1 minus 4 equals 0. So if I bring over my 4, now I can square it. Square root tells me plus and minus, so I get plus and minus radical 15. Now, since I said it was bounded by x equals 0, do I need the negative one? I was telling you we're starting at 0, so we just need after that. So I only need the positive 15. So when I go to integrate this one, I'm going to be going from 0 to radical 15. All right. Graphs, this one is definitely much harder to graph. If we start with the 0, get 0. You know, if you put in 1, you're getting a fourth. If you put in 2, you're getting a half. Put in 3, 3/4. 4 gives you 1. So x over 4 is just like a line, or you can think of it as like 1/4 x. So it's just a line with the slope of 1/4. This one, if you put in 0, you get 0. If I put in 1, I get 1 over the square root of 2. If I put in a 2, I get 2 over the square root of 5. Okay, is this pretty? No. If you were doing this on a test without a graphing calculator, would you necessarily know which one was on top? No. So what if I can't draw the picture? Does that mean I can't set this up? No. It means you take a guess, figure out, put one of them on top, and how do we know if we're wrong? It's negative, and how do we fix it? Absolute value. Okay. So which one do you want to try putting on top? Complicated one. I think that'd be nicer. And I'm going to write x over 4 is just 1/4 x. All right. Here's where it gets a little bit interesting on this problem. Can I erase some of this just so I have more space? Okay. We can break this integral up. And do 2 separate ones. The reason I did this is the 1/4 x is no big deal to integrate, but this one is. What am I going to have to do to integrate that piece? What did we take our last quiz over? So our u would be dx squared plus 1. Du is 2x dx. We need the x and the dx, not the 2. 1/2 du is x dx. So that problem becomes, I'm going to go ahead and change my limits. If I put in a 0 for x, 0 squared plus 1 is 1. If I put in a radical 15 squared is 15, plus 1 is 16. And I have 1 over the square root of u, so I'll write that as u to the negative 1/2. And then I have a 1/2 d. that my whole thing? No, that's just this half of it. Over here, we didn't have to do substitution, so we're just going to integrate this. Antiderivative of 1/4 x, so that would be x squared, you need a 1/2 in front, so 1/8 x squared. Okay, radical 15 squared is 15, so we have 15 over 8 minus 0. So 3 is 24 over 8 minus 15 over 8. Cole did a great job guessing. He put the right one in front. So 24 minus 15 gives us 9 kids. So if one is really ugly to integrate, you can do substitution. If you don't need it for both, you can break up and do one piece of substitution and one without. Okay. That one was exceptionally ugly in terms of the integration piece. Are there any questions there? Okay. So I'm done. Tomorrow, I'm just doing a work day. So trying to give everybody a chance to catch up. I know we've had lots of people in and out. These problems can take a little bit longer to set up. So you have the handout. It's due on Monday. Tomorrow, I probably won't have a video